objective of our video is to understand how simple harmonic motion works, how it is applied to daily problems in real life, also to help other students in need to understand the topic, and how to apply the formulas correctly depending on the situation. Hi, my name is Mira.
Hi Miros, I am Manuel.
Oh, and I'm Andrea.
Oh, I didn't see you there. My name is Rudy.
But what's our test tomorrow about?
Simple harmonic motion.
That sounds really difficult.
Let me show you some things. Well, Miros, simple harmonic motion is pretty easy. It's actually the repetitive movement back and forward through equilibrium. So a side's maximum displacement position is equal to maximum displacement on the other side. Like in a pendulum. You got the pendulum here, right? So the object will displace to the left side as much that it will displace to the right side. That's simple harmonic motion.
First, we need to understand three main concepts. First is amplitude, which is the maximum displacement from the equilibrium point. Next is a period, which is the time taken by a particle to complete an oscillation. And frequency is the number of oscillations performed by a particle during a period of time. Mathematically, the period is the reciprocal of the frequency and vice versa. Here are the formulas.
In simple harmonic motion, we can either describe the two functions with a sine or a cosine function. These two functions represent the given moment of time where the particle will be oscillating in the y-axis. The sine function is the amplitude times the sine of 2 pi times the frequency times the time. And the cosine function is represented by the amplitude times the cosine of 2 pi over the period times the time. After doing the equation, you will receive a y-coordinate that will represent the exact time that the particle is oscillating through the y-axis.
I'm going to tell you what each variable of the function means. A is the amplitude, which we're going to multiply by sine. That is obtained by the graph from the middle of the graph to the top or to the bottom. Then is 2 pi multiplied by f. F is frequency that is obtained by 1 divided by period. Period is obtained from one point to another, from a peak to another peak. If we don't have the period, we can calculate the period by changing the equation 1 over frequency and t represents time, which we're gonna calculate.
Now I'm going to show you how to apply the knowledge of simple harmonic motion in real life. For example, this graph is showing an oscilloscope of the variation in the voltage of an AC in a generator. We have three questions about this. The first one is to find the maximum voltage. The next one is letter B, which is asking to find the frequency that are the cycles per second of the generator. And the last one tells us that we need to find the formula, which is a function that describes the variation of the voltage. how this graph works. Over here we have the maximum voltage, that are the volts of the generator. Then the x-axis means time in seconds. So here it's showing a function of time and volts. So, somebody knows how to solve these problems?
Oh, I know how to solve A.
Come here to solve it.
So to find the max voltage, that is A, we have to know what the amplitude is. So if this is in volts and it starts from 0, it goes to 45. So the answer is gonna be 45.
Oh, I understand. It is because in the graph, it shows that the maximum voltage will not go higher than 45, right?
Yeah, that's right.
In all the graph, it is constant.
Yes, Manuel, well done.
And what about number B?
But I don't know how to do number B.
I know how to do number B. Sit down. Now, to find the period, we need to know the distance from a crest to the crest. This distance, this distance, this distance, etc. So we're going to look to the graph, and the graph does not mark any type of point until the 0.1. Now I know that the graph is divided into 4 parts: 1, 2, 3, and 4. Right? So I got to divide 0.1 by 4. 0.1 by 4 is 0.025. So the distance is 0.025, or the period is 0.025. Now we will substitute 0.025. Now we do a simple division. That is 1 over 0.025, and the answer is 40. So we got 40. We can also, this makes sense because it is cycle per second. So we got 0.1 seconds. To get from 0.1 seconds to 1 second, we're gonna multiply it by 10, because 0.1 times 10 equals 1, right? Now we got 4 times the wave. It means that we're gonna multiply the number of times it repeats by 10. This means that if we take the number of times the wave repeats itself in 0.1 seconds, which is 4, I will multiply it times the time that it takes to get to 1 second, which is 10, get 40, which is the same answer that we got with our formula. So that's a frequency. But I don't know how to do number C. I don't know how to do it.
I can do it.
Oh,
I know how to.
come here and help me.
You'll see. So we already know this formula. We have seen it before, but let's remember. So we have to substitute with the values we have in this case. Let's remember that A stands for amplitude, which in the problem is 45. Times cosine. Over the period we got here, which is 0.025 times time. And the answer given will be a coordinate in the y-axis.
So now, in conclusion, we're going to write the answer for each of the problems. First, letter A. Our maximum voltage is equal to 45 volts. Then, our frequency is equal to 40 Hertz. And last, our formula is x times time equals 45 times cosine times
The other application we're going to talk about that expresses simple harmonic motion is bungee jumping. The simple harmonic motion happens after the free fall. After falling, the cord will have extended to its maximum, and then it will act as a spring, pulling the jumper back into its initial position. Like the spring, the force needed to extend the cord or contract it will be proportional to the distance it's moved. Basically, the jumper will go up and down, constantly through an equilibrium point that can be expressed with the simple harmonic concepts.
In conclusion, now we know how to calculate the simple harmonic motion in our daily lives. At first, this topic was kind of difficult, but then it was very easy.
With this new knowledge, we can understand how simple things work and how they are expressed mathematically.
This video was a challenge for us because the topic was not a lesson in class, so we need to use critical thinking, to research and to work in team in order to know the things.
We keep together as a team to solve these problems and learn more about this topic, so we all know more about basic harmonic